Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from October-November 2022, paper 2, variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together. Let's improve together. For our third question, part A1, we need to define power. And power is simply rate of doing work. If you do work faster, means you do the same amount of work in a shorter time. It means your power is higher. If you do the same amount of work in longer time, it means your power is lower. So simply we can say power is equal to work done per unit time. Work done per unit time. So in this case, if we fix time, if we keep time constant and we increase the amount of work done, it means the power is greater, and vice versa is also true. So for the answer of this question, simply we can say work done per unit time. So if you write on this one, you will get 1 mark. Now let's go to the second part. For the second part, it is given to us that mechanical power can be calculated using the formula F is equal to PV. Use the concept of work and definition of power to show how this formula is derived. And this question has 2 marks. So first thing it is given to us, we have to use the concept of work. So we will write down in this case, work done is equal to force time displacement in direction of force. So this is how you can write down work done. This hint is given to you. So you have to use the concept of work. So we have written W is equal to Ft. Now it is also given to us, we have to use the definition of power. So we can write on power here. Power is equal to work done per unit time, or you can say work done over time taken. And so we can replace W with Fd. So this is Ft divided by T. And in this case, D over T, this is the speed. So D is the displacement in direction of force. So this is D over T. So D over T simply we can say this is equal to speed. So power is equal to force times velocity, or you can say force times speed in this case, force times speed. So this is what you need to do for the answer of this question. So simply you need to say power is equal to force times speed. For part B, it is given to us the engine of a lorry provides 130 kilowatts of power to the lorry's wheels when it is traveling at a constant speed of 25 meters per second along a straight horizontal road. We need to show that the resistive force opposing the forward motion of the lorry is 5,200 newtons. This question is quite straightforward one. First of all, simply we can imagine this is straight horizontal road, and on the top of this road we have a lorry. So this one is the lorry, and there is an engine forced by the lorry that is pushing this one forward. We can say this force is capital F. We can also imagine in this case resistive forces acting on this lorry, we can say are equal to F. So these are the resistive forces, sum of all the forces due to friction and a resistance as well. So we are simply saying these are resistive forces. As this lorry is moving at a constant speed, it means this F has to be equal to this F. So the thrust force in this case is equal to resistive force. So simply we can say power will be equal to F times V, or we can say this is equal to resistive forces times V. We need to calculate in this case resistive force. Fr we need to calculate. So this is simply equal to power divided by the speed of the lorry. And power is given to us, that is equal to 130 kilowatts. So we have to multiply this one with 1000, and we need to divide by its speed. Speed is 25 meters per second. Now if we solve this one, our final answer will be 5,200 newtons up to 2SF. So this is up to 2SF. Because given data, we have 2SF here, we also have 2SF here. So we have to use the least number of SF in our final answer. So this one is our final answer. For part C, it is given to us the lorry in B travels up a straight section of road that is inclined at an angle theta to the horizontal, as shown in figure 3.1. Now the lorry is inclined, mean is going up. The road is not flat, or simply you can say the road is not horizontal. So there is an angle theta. The lorry has mass m and acceleration of free fall is g. For part C1, we need to derive an expression in terms of m, g, and theta for the component of the weight of the lorry that acts parallel to the surface of the road. Component of the weight. So first of all, we can draw our vector for weight, mg. This is weight of the lorry that is acting vertically downwards. So simply we can say this is mg. As this lorry is not moving up and down, so it means there is a force that is acting up here. So there is a normal reaction force. As this lorry is not moving up and down, so it means there is a component of the weight that is acting opposite to that contact force. So here is a component of weight here, and there is also component of the weight that is acting opposite to direction of motion of this lorry. As in this case, this angle is theta, so this angle is also theta. We can say this is normal reaction force, contact force. And this component with angle will be mg cosine of theta, and component of the weight opposite to the angle, that one has to be mg sine of theta. And this component of the weight means this component of the weight, this is parallel to the road. And question is asking us to write down component of the weight that is parallel to the road. So simply you have to write on mg sine of theta in this case. So if you write on this one, you will get 1. For the second part, it is given to us the total resistive force remains unchanged at 5,200 newtons, and the engine now provides greater power to maintain the speed of 25 meters per second. The total mass of the lorry is 36,000 kgs and the angle is 1.4 degrees. We need to determine the power in kilowatts provided by the engine. So in this question, it is given to you the power is greater now. So if the power is greater, it means the thrust provided by the engine that is greater than before. So if the thrust is greater, so the resistive forces also have to be greater. I mean the sum of resistive forces has to be greater than before because the power is greater and speed is the same. So this is one thing you can understand from this question. Now if you look at forces acting on this lorry, as we have already discussed that mg, this is acting vertically downwards, and there is a resistive force that is opposing the motion of the lorry, and that resistive force is mg sine theta. So we can write down mg sine theta. This component of the weight is opposing the motion of the lorry, and this component we have discussed, this is mg cosine theta, and this component is acting opposite to the normal reaction force. And so in this case, motion of the trolley is only opposed by mg sine theta. So if we write down the forces opposing the motion of the trolley, so there are two forces. One force we have already discussed, that was Fr, and that was equal to 5,200 newtons. Then there is an additional force now, that is mg sine of theta. So this is the total force that is opposing the motion of the trolley. So in this case, we can also draw the thrust force provided by the engine. Let's say that is equal to capital F. So now in this case, if we write down the power, the new power provided by the engine, that one has to be equal to capital F times V. But in this case, capital F, that is equal to 5,200 plus mg sine of theta, mg sine theta, and value of angle is given to us in this case, and the speed we have, that is 25 meters per second, and we need to find out value of p in this case. Now we just need to plug in values of mass, g and theta to calculate value of p. So simply we can say in this case we have 5,200 plus m is the mass of the lorry, that is 36,000 kgs, multiplied by g, that is equal to 9.81, multiplied by sine of angle, and angle in this case is 1.4 degrees. Then this all we have to multiply by 25. So if we multiply, our final answer in this case will be equal to 350 kilowatts up to 2SF. Our answer has to be in kilowatts. So this is our final answer, and this is how you can answer this problem. Pretty straightforward one if you read question carefully and try to visualize, not just look at the formula and try to plug in values. You have to visualize. You need to understand the situation, what is given to you and what is happening, and then you can answer this question easily, and also you can improve your understanding of physics. So try to visualize visualize the given problem and then start working on that problem. For question number 4, part A, it is given to us polarization is a phenomenon associated with light waves but not with sound waves. For part A1, we need to state the meaning of polarization. In order to understand polarization, simply we can imagine that unpolarized light. So simply you can imagine this one is unpolarized light. In this case, electric field can oscillate in all possible directions. So these are possible directions. If we pass this unpolarized light through a vertical polarizer, we will get vertically polarized light. So this one is vertically polarized light and this is polarized. And in this case, wave is traveling to the right. So this is direction of travel of the wave. So in this case, simply we can see the angle between wave and this polarized light angle is 90 degrees. And also this electric field is oscillating in only one direction. Or simply you can say it is only in one plane. So it's moving up and down. So oscillations are up and down. So we can say this is in one direction, or simply we can say this is in vertical plane, only in one plane. And direction of wave is at angle of 90 degree to oscillations of electric field. So this process we call is polarization. Means the light waves we can polarize in this way. And this process we call is polarization. But this phenomenon is not demonstrated by sound waves, because sound wave they just move in one direction, and oscillations of the particles they also in the same direction. So the sound waves cannot be polarized, but light waves can be polarized. So let me show you the answer, how you can write on your answer. In your answer you can mention these points. One thing you can say, oscillations are in single direction, which is perpendicular to direction of propagation of the wave. So in this case, simply you can imagine that oscillations are in this direction, up and down. Or simply you can imagine oscillations are in these directions and wave is moving to that. So this is polarization. But if we go to the second part, question is asking you state why light waves can be plane polarized but sound waves cannot. So the reason is that if we imagine a sound wave that is traveling to the right, so in this case the motion of the particles, mean oscillations of the particles, they are in direction of wave, they are moving parallel. So oscillations are parallel. So these are oscillations, these are parallel. So that's the reason sound waves cannot be polarized, because they are just in one plane. So they cannot be polarized. But light waves can be polarized. For the second part, this is how you can write down your answer. Simply you can say light waves are transverse waves. That's the reason they can be polarized. They can oscillate in any possible direction, and oscillations have to be perpendicular to direction of propagation of the wave. So they can be polarized. But sound waves, they are longitudinal waves. They cannot be polarized, because direction of propagation of wave and oscillations of the particles, they are in the same plane. For part B, it is given to us unpolarized light passes through filter A, and filter A has vertical transmission axis. It simply means that after passing filter A, light will be vertically polarized. So this is vertically polarized light. And the intensity of this light is given to us, that is equal to I0. And when this vertically polarized light, it will pass through the second filter, filter B, and filter B has horizontal transmission axis. It means the intensity of the light after passing filter B will be equal to 0, because angle between these two filters is 90 degrees. So cosine of 90 will be equal to 0. You can also use Malus law, IT. This is equal to intensity of incident light times cosine square of theta. And theta is the angle between these two transmission axes. And in this case, angle between transmission axes is 90 degrees and cosine of 90 is 0. So it means that IT in this case is equal to 0. But this is not all about this question. The question is also asking us, filter B is rotated from its starting position about the line xy. So we have this line xy as shown in figure 4.1. After rotation, the intensity of the light emerging from filter B is 1/4 I0. And we need to calculate angle of rotation of filter B from its starting starting position? Very nice question. And so for this purpose, first of all, simply we can draw the lines. We can draw first transmission axis. So this is the filter A. So this is transmission axis of filter A, and also we can draw transmission axis of filter B. So this one is filter B. In this case, the intensity of the light after passing filter B is given to us. That is equal to I naught by 4. So now we can simply use Malus's law and we can find out the angle between these transmission axes. So we can write down IT. This one has to be equal to I naught cosine square of theta. And theta is the angle between two transmission axes. So in this case, IT is given to us. That is equal to I naught by 4. And we have incident intensity and cosine square theta. I naught we can cancel with I naught, so we can write down cosine square of theta. This is equal to 1 by 4. So cosine of theta, this will be equal to 1 by 2. And cosine of theta is equal to 1 by 2 if theta is equal to 60 degrees. So it simply means that the new angle between these transmission axes is equal to 60 degrees. So we can draw here. So this is filter B now. So B is placed like this now. So the angle between them is 60 degrees. We can draw this one. So this angle is 60 degrees now. This angle is 60 degrees. But this is not our answer. We need to find out angle of rotation. So how much we have rotated this one? If you look at this direction of rotation, this is clockwise. So we have rotated this one clockwise. So I'll be using black color. So first of all, we have horizontal filter placed like this. This is transmission axis of horizontal filter. Then we rotate this one and we bring this one into this form. So how we can rotate this one? One way to rotate first of all this one by 90 degrees. So we can rotate this one by 90 degrees. So this is by 90 degrees. So we can just rotate by 90 degrees. Now if you rotate this one again by 60 degrees, so this will align with this. So in this case, the total angle of rotation we have, that angle of rotation is, first of all, this 90 plus this 60. So this is 60 because alternate angles are equal, plus 60. So what is total angle of rotation? So in this case, so we can say angle of rotation in this case is equal to 90 plus 60. 90 plus 60. So the angle of rotation is equal to minimum angle of rotation in this direction. That is equal to 150 degrees. So you can write down your final answer. Angle of rotation is 150 degrees. But you can also write down, you can rotate further this one. So we can use a different color now. We can use, let's say, orange color. So we can place our filter here first of all. We can rotate this one first of all by 90 degrees. First of all, we can rotate this by 90 degrees. Then again, we can rotate this by 90 degrees. And again, we can rotate by 90 degrees. So 3 times we have rotated by an angle of 90 degrees. And if we again rotate by angle of 60 degrees, so we can align this one with A at an angle of 60 degrees. So in this case, you can also say the total angle of rotation. You can say 90 times 3 plus 60. So this one will be equal to 270 plus 60. So you can also write down 330 degrees. So this answer is also acceptable. So if you write down 150, 330, both answers are acceptable. So this is how you need to answer this question. I hope this one is clear to you. If you have any questions, please leave your. For part C, it is given to us a microwave of intensity I naught and amplitude A naught meets another microwave of the same frequency and intensity of I naught by 4 traveling in opposite direction. Both microwaves are vertically plane, polarized and superposed where they meet. For C1, we need to explain without calculations why these two waves cannot form a stationary wave with zero amplitude at its nodes. So first thing we need to understand, when two waves they meet and they have zero amplitude at nodes, when that is possible. That is only possible. Imagine that we have two waves. Let's say we have wave 1 and let's say we have another wave. We can use a different color. Let's say we have another wave. So this is another wave. And these two waves, they are traveling in opposite directions and they have the same amplitude. Let's say amplitude of this wave is A naught and amplitude of this wave is also A naught. And when these two waves, they will meet, let's say they meet at this point. So we can draw the amplitude of one wave. So this is amplitude of one wave, and the other wave we can also draw. So this one is the other wave. So we can also draw over this wave. So just 1 minute. So we can draw in a proper way. So we can draw this is over other wave. So in this case, when these two waves, they will superpose, the resultant amplitude of resultant wave will be 0. Means they will cancel each other completely. So complete cancellation will take place in this case. So the resultant amplitude will be equal to 0. You can also understand A naught minus A naught. This one will be equal to 0 at any point. Means if I take this displacement of this wave, I will take this displacement. One you can see negative, one is positive. If I take maximum displacement amplitude, these two also equal but in opposite direction. So resultant amplitude will be 0. And so this is possible when two waves, they have the same amplitude. But in this case, the amplitude of waves is different because the intensity is different. Actually, amplitude of this wave will be equal to A naught by 2 because its intensity is 1/4 I naught, and intensity is equal to K times A square. So this, if this one is I naught by 4, this has to be A naught by 2. So in this case, we have one wave. You can, again, we can draw. We have one wave here. So this is one wave. And other wave we have, we can use different colors. So let's say we have this another wave. So these are two different waves in this case. So this wave has amplitude A naught, and this one has amplitude A naught by 2. So when these two waves, they will meet. So let's say they meet at this point. So we have red wave, we can redraw. So this one is the red wave. So these two waves, when they will meet, they will not cancel each other 100%. So in this case, they will be resultant wave. So the resultant wave, we can use this dark color. So this one will be the resultant wave. So this is what we will see. So in this case, there is no complete cancellation. Amplitude at node cannot be equal to 0. So these points you need to understand. So if you have understanding of these points, so simply we can write down our answer. In our answer, you can mention these 2 points. Waves have different amplitudes, so cannot have resultant displacement. That is always 0. So this is how you can answer. For the second part, we need to determine in terms of A naught, the maximum amplitude of the wave formed. Means the resultant amplitude of resultant wave of two progressive waves. So how we can find out? We have wave 1. Wave 1 has intensity I naught, then amplitude of wave 1 is A naught. And the second wave has intensity, that is I naught by 4. So we can find out the amplitude of the second wave. We can say amplitude of second wave is A2. And we can find out value of A2. And so in this case, we need to understand the ratio between intensity and the amplitude square. This one is constant. So we can say I naught by 4 divided by A2 square. This also will be constant. So we can simplify this one. We can say I naught by A naught square. This one will be equal to I naught divided by 4A2 square. A2 square. So in this case, I naught we can cancel with I naught. So then we can write down 4A2 square. This one has to be equal to A naught square. We need to find out value of A2. So A2 we need to find out. So we can write down this is A naught square by 4. So this is A2 square. And from here we can write down A2. This one will be equal to A naught divided by 2. Because if we take square root on both sides, we will get A2 is equal to A naught by 2. So the A2 is half of the amplitude of wave 1. Half of amplitude of wave 1. But question is asking us to calculate the maximum amplitude. So in this case, we have two waves. So we can calculate A max. Maximum amplitude is when waves interfere constructively. So simply you need to add their amplitudes. So we have A naught plus we have A naught by 2. So this is simply equal to 3 by 2 A naught, or simply we can say this is equal to 1.5 A naught. So this is our final answer, 1.5 A naught. Quite straightforward question. So if you have basic understanding of intensity, so intensity over A square, this is equal to constant. So, and that is true for both waves. So that's the reason we can compare that. So the ratio between I naught and A naught square, and ratio between I2 and A2 square is constant. So we can equate and we can find value of A2. And when we have value of A2, simply you need to add that, and you can find the maximum amplitude of resultant wave.